Well, here we are, lesson 7.4. 7.4. We are on sine and cosine ratios. Sine and cosine ratios. Okay, yesterday we got familiar with using the tangent ratio, and we figured out that the tangent ratio was a ratio that compared two side lengths in a right angle triangle. So let's say we're looking from angle A in this triangle. In order to get the tangent ratio, I would take the ratio of opposite over adjacent, right? And we would read that like this, the tangent, and we can call this angle theta. The tangent of theta is equal to opposite over adjacent, okay? Well, it turns out that that is only one of the three primary trigonometric ratios, okay? So in that top little section there, you have a note that we're going to take on primary trigonometric ratios.
I don't like those ones.
Primary trig ratios, okay? What are they? Well, their names, these markers are bush. Their names are sine, often just denoted SIN, cosine, often COS, cos, and tangent. And what do they do? Well, they relate sides and angles within a right angle triangle. They relate sides and angles within right angle triangles. So this is a really key tool in your toolbox when you're dealing with right angle triangles, okay? So what are these ratios? Well, let me draw a triangle over here. Okay, here's our right angle triangle. I'm going to call this angle theta, and we're going to do all of our trig ratios from that angle. So let's identify our sides first. We'd have, from here, I'd have opposite and adjacent, and the hypotenuse is always across from the right angle in my right angle triangle. So now the primary trigonometric ratios are, we can take the sine of theta, okay? And the sine of theta is going to be the relationship, the ratio of opposite over hypotenuse. Opposite over hypotenuse. So the same way that we worked with tangent yesterday, you can work with sine. It's a different ratio. So you can take the sine of theta, that's going to relate opposite and hypotenuse. Yesterday we would have taken the tangent of theta, it would have been opposite over adjacent. Okay, so it's a description of the ratio of two sides within a right angle triangle. We can also take the cosine of theta. The cosine is the ratio adjacent over hypotenuse. And tangent, we know from last time, is opposite over adjacent. These are the three primary trigonometric ratios, okay? That means if we just look at one of our sentences here, let's just consider this. There are three pieces of information involved in each of these math sentences. Here you have an angle, a side length, and a side length. That means if we know two of those pieces of information, we can always find the third piece. So if you are missing or you're wondering what the angle measurement is here, if you're wondering what this angle is, but you know this side and this side, you can use the sine ratio to get that ratio, opposite over hypotenuse. It's just going to be a number over another number. You can take the inverse sine of both sides, and that will give you the angle measurement. Okay? Let's say you don't know the sides, or let's say you know one of the sides and you know the angle. Well, then you can work your division triangle. If you know the angle, then you just in your calculator, you can take the sine of that angle. That means you know that whole piece, right? This is just something you do to that value. So if you know that value, then you know this piece of information. And then if you know, or if you want to find out the opposite side, you just multiply by the hypotenuse, both sides. Okay? And we'll work through some of that. One of the keys, really the only main key, not the only main key, but one of the main keys, is determining which of these primary trigonometric ratios is actually going to help you solve the problem. So for example, maybe we'll do a little quiz right now. I want to know the angle, and I do know the hypotenuse and the adjacent, but I don't know the opposite side. What trig ratio will I use to solve that problem? I have to use cosine. It's the one that gives me the relationship between adjacent and hypotenuse. That's the information that I have, looking from angle theta. Therefore, I would have to be finding out the cosine of theta, then get the inverse of that will give me the actual value of theta. Okay, quiz again. Let's say I know the opposite, I want to know the adjacent, and I do know theta. Which trig ratio am I going to use? I'm going to use tan because it's the one that involves theta, opposite, adjacent. Okay, I have two pieces of information. I'm missing the third piece, but I can figure it out using this equation. Last quiz. Let's say I want to know the hypotenuse, I know the angle, and I know the opposite. Yeah, I'm going to use the sine ratio because that's what involves the angle, the opposite, and the hypotenuse. And using that, plugging in my information, I'll be able to find out the hypotenuse. If I have two pieces of information in a right angle triangle, I can solve the triangle. I can find out what the measure of the angles are, and I can find out the length of the sides. Okay? So let's head right into example 1. We're just going to be applying today sine and cosine. And as we get into solving whole triangles, we'll talk about what that means, or solving problems, word problems involving triangles. Then we'll be choosing between all three of these. There's one other helpful tool that hangs around in my toolbox when I'm dealing with triangles. What is it? When I'm dealing with angle measurements within a triangle. Okay, so that doesn't deal with angles. Pythagorean theorem deals with side lengths, so that's a helpful tool. Maybe we can just make a note. Other tools in the toolbox. We've got Pythagorean theorem. This is for side lengths. And we have the sum of interior angles. Sum of interior angles equals 180 degrees. Okay, so those are two tools you're going to keep with you as we move through all of these problems. Okay, how do we remember these primary trig ratios and what ratio to use in certain situations? How do I remember this information without writing it out every time or having to really think about it hard? Well, again, we're looking from angle theta. So if we just identify our sides quick, we've got opposite, the side opposite the right angle is the hypotenuse, and we've got adjacent. There's a little bit of a rhyme. It's not a rhyme. It's more of an acronym to help us remember this thing. And it is so, ka, toa. Okay? Or if you really want to remember it, so, ka, toa! Yeah?
Nice.
You good with that? So, ka, toa! So, ka, toa! So, ka, toa! And now you'll never forget it. Isn't that great? So if you have opposite and hypotenuse, you're going to use sine ratio. If you have opposite and adjacent, you're going to use the tan ratio. If you need the hypotenuse and you have other stuff, you can use cosine or sine ratio. Make sense? Okay? And you have to always remember though, so now that we've shortened it to sol katoa, you have to really remember that this means, the translation of just this piece means that the sine of an angle, is the relationship or ratio between two sides. So now we've cut a lot of this information out. We've cut out this part from our rememberability trick here. But you have to remember that that's still in there. So many of you guys, students in general, will start going like, oh, okay, yeah, I take the sine of, the opposite is 4 over 5. Oh boy, the angle must equal that. No, wrong. Don't do that. Okay? The sine of the angle is equal to the ratio of side length over side length. Okay? Excellent. Okay, so we have example 1. We're going to use the skills that we just took notes on. We're going to find the primary trigonometric ratios, okay? So it's given us the 3 side lengths in each of them, and we're going to be developing the trigonometric ratios. So we're going to be finding sine of theta, we're going to be finding cosine of theta, and we're going to be finding the tangent of theta, okay? This is the sine ratio is going to be what over what?
It's going to be opposite over the hypotenuse.
Op over hype. Cosine ratio is going to be
Adjacent over hypotenuse.
adjacent over hypotenuse. Tangent ratio is going to be
Opposite over adjacent.
opposite over adjacent. Maybe after this I'll give you a little trick to remember them. It involves me yelling, so that's always fun.
Yay.
Okay, so all I have to do to determine this ratio is, I'm just going to work across even though that's cheating. I just have to find the opposite side length. So I'm looking from angle theta. So I can identify my side lengths, opposite, adjacent, hypotenuse. And if that's helpful to you, you can write it in there. Eventually, hopefully you don't have to do that. But there's my side lengths. That's their names. And I just have to plug it in. Opposite over hypotenuse. 10 over 26. 10 over 26. I'm going to check that in my calculator to round it to a decimal with 4 decimal places. Okay? And that is 0.3846. Now again, when you're finding this ratio, you're always going to keep at least 4 decimal places. And if you're using them in a multi-step problem, you're actually going to try your best to just leave that information saved in your calculator and not round at all until the end. We'll talk about that when we get there. But this is the ratio. You plug it in. Now this, don't get tricked. This number is still a ratio. 0.3846 is the ratio of opposite over hypotenuse. Okay? Next one, cosine is adjacent over hypotenuse. Adjacent, 24. Hypotenuse, 26. Chuck it in your calculator, round to 4 decimal places. Please do this in your calculator so that you can make sure that you're getting the right numbers. That's 0.9231. Again, all you're doing, we're not finding out what the measure of angle theta is. Okay? We're not even finding out the measure of angle theta. We could. We would just have to take the inverse sine of 0.3846 or the inverse cosine of 0.9231. And we'd get the measure in degrees of angle theta. That's not what we're doing here. We're just getting the ratios. Opposite over adjacent is the tangent ratio. So you got 10 over 24 equals approximately 0.4167. 0.4167. You're going to notice something really interesting about the sine and the cosine ratio. The numbers will always be between 0 and 1. In the tangent ratio, it can be a much larger number. In this case, it's not, but yeah, go from there. Okay, go ahead and do the next triangle as fast as you can. And double check your answers at the board. So whenever it's asking you to find the primary trig ratios, it means all three of these. Sine ratio, cosine ratio, tangent ratio. Again, you might want to identify your opposite, adjacent, and hypotenuse, looking at this triangle from the perspective, the vantage point of angle theta. And when you're done, you can double check your answers on the board. Rounding to 4 decimal places. Keep lots of accurate information there. And again, our next example is going to do this for us, but if I ever wanted to find out what angle theta actually is, looking back at A, let's just take the cosine ratio is 0.9231. All I would have to do is take second function cosine, that'll be the inverse cosine of 0.9231. Enter. It gives me an angle of 22.6 degrees. Okay, so for this one, theta equaled 22.6 degrees. Do you think I'll get a different number if I take the sine of the sine ratio, inverse sine of the sine ratio? Or you think I'll get 22.6 again?
Probably 22.
Yeah, hopefully. I'll be close anyway. Second function sine, 0.3846, enter, 22.6. Makes sense that they're the same because it's the same angle. And if I took the tangent and I took the inverse tangent of the ratio, I'd get the same thing. Okay? So no matter which one you use, the angle's not going to change. You just have to use the one that you have the right information to use. Here we have all three sides, so I can pick any one I want. Quite often you'll only have two sides, and you have to pick the one that matches best. Well, the only one that you can use. Okay, example 2 is exactly the same type of example we did yesterday. It's literally just getting you to punch it into your calculate. You're evaluating the sine ratio of 26 degrees. Now, you don't have a triangle. You don't know opposite, adjacent, hypotenuse. You don't know anything about this triangle, how big it is. It might be, 26 degrees in a little triangle, or it might be 26 degrees in a much larger triangle. Okay? It might be 26 degrees angle in a massive triangle. You don't know. But if you know that the sine ratio, you can calculate in your calculator, you can get the sine ratio of 26 degrees. Sine is opposite over hypotenuse. So basically it's going to give you this side length over this side length, no matter how big the triangle is. And it will be the exact same ratio. The comparison of opposite to hypotenuse will be the exact same if you're in that big triangle as if you're in this little triangle. And the ratio will be the exact same if you're in this medium triangle. Does that make sense? The comparison between this side and this side will be the same. They grow and shrink at the same rate. So the fraction that they make will be the exact same. It's like saying, okay, if one side is 4, the other one is 8. And if I shrink my triangle, I might have a situation where one side is 3 and the other one is 6. And if I stretch my triangle, I might have a situation where one side is 10 and the other side is 12. That's wrong, 20. Okay? But the ratio is the same in all of these. They all reduce to 0.5. No matter how big my triangle is, no matter how small my triangle is, the ratio, if the angle is constant, is going to be equal. Okay? So, sine 26, all I have to do is punch it in my calculator. Sine button, 26, enter. Keep 4 decimal places. It's approximation 0.4384. Make sure you're rounding proper on that last digit that you type. B, same thing. You're going to take the cosine of 75 degrees, punch it in your calculator, round to 4 decimal places. You're going to have 0.2588. Always remember that your calculator in that screen at the top has to have a D in it. That means you're measuring in degrees, or maybe yours is a DEG somewhere in it. Okay? If you see just a G or just an R or a RAD or a GRA, you're in the wrong setting. Okay? You have to change it, your mode, or you might have a little button somewhere on your calculator that says DRG or DGR. That one will change it, or you might have to go into your settings, change your angle measurements to degrees, because you can measure angles using different units, just like you can measure a line using, centimeters or miles or feet or whatever you want. Okay? Okay, here we go. We're solving a word problem. We're in example 3. At the beginning, at the top of every single one of my practice problem pages, I'm going to be writing so ka toa. Okay.
Nice.
And example 3. Please pay attention. Underline any important information. Captain Jack, navigating his ship to Port Harbor. It's directly north of the ship's location. Do. Captain Jack. Port Harbor. But he has to compensate for an easterly current. So he aims for a point on the shore that is 5 kilometers west. 5 kilometers. Right here is where he's aiming for. We're going to call that the point that's west. And so we've got Jack. He is charting his ship this way. The wind's going to push him this way. And he's going to end up at port. Okay? Make sense? All right. We know that the place that he's heading is 20 kilometers away. And we know that it's 5 kilometers away from port. So I think what we're trying to find out is what bearing he needs to head his ship on. Oh boy, Mr. B, what is a bearing? That doesn't make no sense to me whatsoever. Okay? Quick note down here at the bottom. Draw a little compass. North, east, south, west. Okay? And in order to determine the bearing is always measured. It's expressed as an angle in terms of north, south, east, and or west. So this bearing, let's just draw one. Do you have an example in your book or no?
We have just north.
So let's say that we wanted to head 65 degrees east of north. So if not north, but you're going to go then turn 65 degrees toward east and then start going. Okay? This angle can be called north and 65 degrees east. Okay? What does that mean? We would read that as 65 degrees east of north. Okay, so when it says bearings, it will give you the bearing something like this, and you're going to be heading, in this case, 65 degrees east of north. So you're pointing north, and then you turn 65 degrees toward the east. Okay? Just as a little extra one. Let's say, how do I want to do this out of the way? Let's say this angle in here is 20 degrees. How would I write that?
20 degrees.
Well, I'd say it 20 degrees west of north, and I would write it as n 20 degrees west. Okay? And you can do this for angles heading northwest, northeast. You can also do it for angles heading south. Okay, if you know the angle in between them, let's say you know that this angle right here is 70 degrees. Then this one is S 70 degrees east, or 70 degrees east of south. Okay? So here we go. We need to give the bearing that Jack is going, which basically means that we're looking up this line, which is heading due north, and we're looking for this angle right here. Okay, so on my diagram, I'm just going to call that angle theta. That's the one I'm looking for, because that will give me the direction west from north. Okay, here we go. We got a nice right angle. We know two of the side lengths. If I'm looking from the hypotenuse, which side lengths do we know? Opposite, adjacent, or hypotenuse? What do I know?
We have opposite and adjacent.
Opposite and hypotenuse.
We have opposite and hypotenuse.
Thinking smartly.
Okay? So be aware of where your right angle is, and the longest side is always the hypotenuse. Okay, so if I have the opposite and the hypotenuse, which ratio am I using?
You are going to use
Sine ratio. I'm going to remember that this actually translates into the sine of theta is equal to up over height. The sine of theta is equal to 5 over 20. Okay? Now, I could put this in my calculator and figure out that 5 over 20 is 0.25. Okay, it's 1/4. I don't have to do that. Instead, what I'm going to do is right off the bat here, I'm going to take the inverse sine of both sides. Okay, so I'm going to take the inverse sine of this side and this side. If I take the inverse sine of the sine of theta, what's going to be left? Just theta. And then I take the inverse sine of my ratio. And again, I can write that as 5 over 20. I can write it as 1 over 4. I can write it as 0.25. And now in my calculator, I very carefully, on clear second function, sine is going to give me the inverse sine command. 5 divided by 20. Enter. Make sure you close that bracket if you're doing a calculation, if you're doing an operation inside the ratio there, you haven't reduced it to decimals, then use that. Okay, so we're told here that the angle then is 14.5 degrees, and we're just going to round that to, it's an approximation, so we're just going to make it 15 degrees. So angle theta equals, we'll give an answer here of 14.478 degrees. So, Captain Jack must head on a bearing of, well, let's think about this. We're going north, so we start with an N. And then we're going to go about 15 degrees west. Okay? Now I told you that there was a way to do this just keeping answers saved in your calculator. I'm going to do it this way just so I can show you. Okay, and I'll even jot down what I do. But the alternate method here for putting this in your calculator is do 5 divided by 20, hit equals. You'll get an answer. Okay, let's just say, yeah, let's say you get 0.25. Now, sometimes this comes out nice and clean like 0.25, but sometimes it's a stream of decimals, and then if you used that answer again, you'd probably round it to 3 or 4 decimals, and you'd have a rounded answer inside your rounded answer, which is like double rounding, and you're losing a lot of mathematical information that way. So here's what you do. You then take the inverse sine. But instead of typing 0.25, you use the second function answer key. Then what your calculator does is it puts in that spot the previous answer that you did in your calculator. It stores that answer and it plugs it into the next operation. Okay, so here's what that looks like. We would do 5 divided by 20. That gets me my sine ratio. So my sine ratio is 0.25. In this case, it's easy. Often it's a whole string of decimals. And your calculator actually stores the exact answer, but it can only show you, 8, 10 decimal places. So your calculator actually has more information in it than it can even show you, which is why this is so helpful. Then what I do, second function, sine. Second function, here's my answer key. It's on top of the negative. Answer, I can just hit enter. Boom, 14.4775, same answer. Okay? Again, in this exact case, it doesn't make that big of a difference because this is easy to punch in. But same answer. If you do it that way, this will store the previous answer, plug it right in when you need it. Okay, that was A. Let's look at B. What does B say? B says Captain Jack is in communication with a submarine that is cruising at a depth of 400 meters below sea level. If Jack's radar tells him that the submarine is 500 meters from Jack, due north of his ship, at what angle is the submarine located with respect to Captain Jack's ship to the nearest degree? So, again, I'll erase what I have here. This one's a little bit trickier to think about. Okay, we're going to always start these ones by drawing a picture. Example 3b. So we've got Jack. He's up here. Okay. He gets this radar that says, well, his radar can read, what was it, if it's within 400 meters, within 500 meters?
That is 500 meters.
So it's cruising at a depth 400 meters below sea level. That's where the submarine is. So the submarine, let's say this is 400 meters. And it could be anywhere along this line. Does that make sense?
Well, it does say it's 500 meters.
Okay. And we know that it's 500 meters away from his ship. So let's say that this line is 500 meters. And let's say that this direction Jack is heading is north. Okay? Does that make sense? So it's north of the ship. And we don't know how far north of the ship it is. But we know we have a right angle here. The submarine is cruising somewhere along here. If it were south of the ship, it would have been down here somewhere. But it's not. It's north of the ship. So let's call that S. And we know this direction is heading north. Okay? Well, what do we have? We need to find what angle is the submarine located at with respect to Captain Jack's ship. So we are looking for this angle. Okay? And it's going to be toward the north. And so now we're just looking at this and thinking, okay, well, if I'm looking from Captain Jack, what side lengths do I have?
You have the hypotenuse and the... Oh, yeah, that's the...
Hypotenuse and adjacent. So which ratio am I using?
You are using... hypotenuse and adjacent, yeah.
I'm going to use cosine. I know that the cosine of the angle, I don't even know the angle, but I do know the cosine of the angle. I know the ratio of adjacent over hypotenuse. Cosine of theta is 400 over 500, which, by the way, reduces to 4 over 5. Take the inverse sine of both sides, tells me that the angle is going to be approximately, well, actually I'll do exactly because I'll do one more step. It's going to be the inverse cosine of 4/5. Go ahead and plug that in your calculator. You will get an approximation for your angle.
Inverse. It doesn't work.
Did you do 5 over 4 by accident?
Nope.
All right.
36.8698.
The submarine, the sub is approximately 37 degrees north of the ship. That's with respect to this line pointing down to the bottom of the sea. Straight down. All right. So word problem, it sounded really challenging. All we had to do was identify a right angle triangle, draw it out, figure out what side lengths we have, use that to determine our primary trig ratio, and then use the primary trig ratio properly in order to determine the angle measurement. Okay, one more example here. And before we take that one more example, we just put a little note at the top of the page there. Or right under. You'll have space, actually, if you just do it right under. Example 4. A little note to solve, or let's just do this. Solve this triangle. Put that in quotes. Solve this triangle means find all the sides and all the angles. Means find, let's do it in a jot note form. Find the measure of every angle and find the length of each side. And you can replace every with each or each with every. I don't really care. But solve it means by the time you're done, you'll have all the information that you could get from that triangle. All the sides, all the angles. Okay? If you haven't done that, you have not solved the triangle. So when you get on a test, solve the triangle. And you solve, for the side length W. Great, you're not done. Keep going. Oh, you did both side lengths that were missing? Great, way to go. Find the angles. Okay? Solve it means do it all. So here we go. We have this triangle ABC. Right angle at B, A, B, C. They give us some information, because without that information, you'd never be able to even start. Okay? And the information that they give me is going to dictate how I start this thing. Okay? Well, I know that, let's talk about angles first. Why would I want to do angles first in this situation? What would make me...
Angles are important.
You have both already.
I already have 2 of them, so I only have one more trick to get this third one. It's pretty easy, okay? So for the missing angle, I know angle C is going to be 180 degrees minus, and watch how I write this. It's helpful for your calculator, but basically I have a 90 degree and a 30 degree, so I'm going to add those up. And then I'm going to subtract whatever I get from that. You could also do it this way. You could do 180 minus 90 minus 30. Okay, that works. Algebraically, all you did there was distribute this negative sign to the 90 and the 30. You could also just do 90 minus 30, because you know that A plus C is going to be 90. Anyway, because 90 from B is already gone from the 180. Either way, angle C equals 60 degrees, okay? I'm going to keep track of all my information as I go along. And then at the end, I'm going to put all my information that I found out in a box, a nice, neat final answer. Okay, that was my angle. So now I'm done. My angles. Solving a triangle, real hard, okay? That was easy. Next, I have 2 missing side lengths. Which one would you like to find first?
Let's do BC.
BC? Okay. So now here's something you need to know as well, and we haven't maybe talked about this, and maybe I should have drawn my triangle a little bigger to describe this. We know that angles, vertices, are named using capital letters. Side lengths are named using lowercase letters, and the lowercase letter is the same letter as the opposite angle. Okay? So if this is vertex A, then this is side length A, opposite. If this is angle B, then over here we have side length B. And if this is angle C, then over here we have side length C.
If we do not
Okay.
use lowercase letters, we will lose marks.
Yes, every time. Yep. Yes, you must use capitals for your angles, for your vertices, and you must use lowercase for your side lengths. Now, one tricky thing that just happened here, we're in a right angle triangle. I use the letters A, B, C, but is this statement true?
No.
It is not true. What is my hypotenuse?
No.
So if I'm going to use the Pythagorean theorem, which I often will, I need to make sure that it's done properly with the two legs. The square of the two legs being added equals the square of the hypotenuse. Okay? So pay attention to that as you move along. Don't accidentally do a squared plus b squared equals c squared when it's not appropriate to do so. All right, so you wanted to find side length A first. So let's look at what I have here. I have from angle A, looking at it from angle A. I have the adjacent and I'm looking for opposite. So what ratio am I going to use? I'm going to use tangent. Okay, so now I know that the tangent of A is going to be equal to op over adj. That's the one I've chosen to use. I know angle A is 30, so the tangent of 30 is op, that's A, over adj, that's 20. Next step in the world of algebra to solve for side length A.
Wait, how do we know that A's on that way?
Multiply both sides by 20. That's going to leave me with just A. And this, 20 times the tan of 30, I can type that in my calculator exactly how it says it there. All 2, 0 times, you don't even need the times actually, 2, 0, tan, 3, 0, enter. 11.5. Approximately 11.5. And that's measured in, doesn't say, so just any units. Good. As I'm going through, I probably will box the key information that I found. Now, there's two ways to get the length of AC. Do you know those two ways?
Yes.
I could use Pythagorean theorem or another trig ratio. We're going to do it with another trig ratio because that's what we're doing today. But, question, I just found this answer. I just found the opposite side length. Am I going to use that in my next calculation if I don't have to?
Probably not.
No, I'm going to use the exact values that they gave me again. So now I'm looking for hypotenuse, okay? And I have adjacent, and I have the angle. So adjacent and hypotenuse. Which ratio deals with adjacent and hypotenuse? Cosine. So now I know that the cosine of angle A is adjacent over hypotenuse. No, you don't need to write this every single time when you're doing your practice problems. Cosine of 30, because the angle A is 30 degrees. Adjacent, I know, is 20. And hypotenuse is called B, or I can call it AC. Either name is good. I'm going to call it angle B. Now, I would have to, like yesterday, I would have to multiply both sides by B, then divide both sides by cosine of 30. But if I understand how my division triangles work, I've got 20 in the top, I've got B in the bottom, and I've got the cosine of 30 in the bottom. So if cosine of 30 equals 20 over B, then B equals 20 over cosine of 30. Okay? 20 over cosine of 30 equals B. So that's going to be my next step. B equals 20 cos 30. This looks confusing. Take a little digression again here. This looks like just a string of, whoa, what's going on there? What's the default operation in algebra? Okay, so this is just a ratio. That's just a number. This is a constant. And in between them, multiplication. Okay? In your calculator, all you have to do is type 2, 0, cosine 3, 0, enter. And you will get that b equals approximately 23.094.
What?
No?
wrote less than.
Yeah.
Okay, it might be a mistake in the book. 20 divide... nope, that's because Mr. V made a mistake up here. I wrote it wrong. One mistake. Okay, that's because b doesn't equal 20 times cos of 30. It equals 20 over cos 30. It says so right there. 20 over cosine of 30. Alright, so that one you punch in your calculator a little bit differently. Well, probably the same.
It's 23.
Yeah, you can do it probably without thinking too much. 20 divided by cos 30, enter. Should give you 23.094. If you get that answer, you would just, round to the nearest degree. It's not degrees, sorry. You'd probably round to the nearest decimal, which is 23.1. That's what we did over here, was 1 decimal place. And you have solved the triangle. Okay, there were only 3 pieces of missing information. And there were 3 pieces given. This was given, this was given, and this was given. So we had to solve for B, A, and angle C. All right. Identify the primary trigonometric ratio that's going to help you the most. Often you'll only be able to use one. And then you have some other tools in your toolbox you can use as well. Pythagorean theorem, and the sum of interior angles is 180 degrees. Your practice problems are from page 338, numbers 1 through 10, and from page 344, numbers 1 through 11. Go for it.
Are we moving on?